them negative on there just for kicks. So times negative 0.655. It moves, it displaces itself negative 26.5 meters downstream. What does that mean? If we go downstream negative 26.5 meters, we went upstream. In fact, I think this is what Max was showing us in that demonstration, right? You let it go upstream that first time just to show this example problem, right? Yeah, I know. He was thinking that, right? So instead of actually going downstream 41.4 meters, we went upstream 26.5. We actually, not upstream as far as we would if the current weren't there, but we ended up going upstream. Yeah? And then one of the questions says, what is the velocity as seen from above? So if we were hovering in a helicopter, we would see this velocity in the x direction or across. Upstream, we'd see it moving this velocity, right? And we could make that into a triangle. We could find the magnitude of the triangle and the angle and all that stuff. But you guys are so smart. I see that you yearn for more, don't you?
My knowledge.
Yes. You want more knowledge, okay? So the final example is, how do we go straight across? How do we figure out that perfect angle? Right? We want a perfect angle so that we go straight across. Right? So across, downstream. Across is that way, downstream is this way. Here's the river. We're now pointed at the miracle angle. Yeah, this is the last one. The last example. After this, I can't teach you anymore. You'll be like young Jedi masters. You'll know all the things. You just have to practice them. And apparently lift spaceships up and stuff and then drop them back in the swamp and stuff like that, right? Okay. Still 120 meters across our river. There's still a current of 1.2 meters per second going downstream. And now we are going to make that perfect angle so that we go straight across. Okay? So what do we know and where do we know it? What do we know? 120 is our across, yeah? There's a 1.2, okay, hold on. If we go straight across, what's our downstream displacement? 0. That means that 1.2 plus something adds up to what? 0, doesn't it? So what that means is when you have that perfect angle straight across, this upstream component exactly cancels out the current, yes? Precisely and exactly cancels out the current. So what does it have to be? Negative 1.2, right? So this thing is 1.2 there. The hypotenuse is 3.5 because that's the speed of the boat, right? How do you find that side? How do you find that side? Write this down. Make this in your cheat sheet because you're going to need this. Right? Make sure you like circle this, highlight this. This is on the test. You got to be able to figure this out, right? How do you find this side of the triangle? Can you do Pythagorean theorem? Yeah, you sure can. You sure can. Right? So 3.5 squared equals x squared plus 1.2 squared. X squared. So take your calculator and calculate what x has got to be. That's just the hippopotamus. Isn't it great that the math teachers taught that to you so you could learn physics? You were wondering when you were in math class, when will I ever use this? Except for like carpentry and a lot of other places, right? But you're probably wondering, when might we ever use this? This is how, right? You can, this whole Pythagorean theorem, this is how carpenters measure to see if a room is square, is you measure along the wall, and you measure diagonally. If the Pythagorean theorem works, it's square, and if it doesn't, it's not. Do you guys get that side is 3.288, roughly? Yeah? Are we good so far? 3.7. I did square root of 3.5 squared minus 1.2 squared. Huh?
Is it 1.2 squared because it's negative, so not positive?
No. No, this is a case where your TI calculator will just evaluate that, and you know. It's not negative 1.2, the quantity squared. Are we good? Did everybody get that? Should be numbers smaller than one of the sides, right? 3.288. So that's going to be this velocity here, right? 3.288. Isn't it? And then can't we figure out the time to cross? Can't we? The time is just going to be this divided by this, so 120 divided by 3.288. So I'm going to take my answer, raise it to the negative 1. This is how lazy I am. Multiply by 120. 36.5 seconds to that. So less time than it took when we had to go upstream. More time than it took to go when we pointed straight across. Yeah? So pointing straight across is always the fastest way to cross the river, right? But if we want to go straight across, we've got to counteract the current. That takes a little more time. Anybody else get that? Am I right?
I got it right.
You got it? Okay. If we agree, I mean, our IQs have got to add up to like 100, so, you know. Yeah. You're gesturing. I don't. 36.5 seconds would be our time. Okay, so why are these maneuvers, when you do them with a canoe, why are they called a ferry?
What are they called what?
Why are they called them a ferry? What is a ferry, besides the thing with wings? The boat that does what? Ferries. Ferry you across cars recently, but before it was horses and wagons and stuff, yes? Yes?
It was.
Okay, and with a ferry, right, the road goes here, Boone's Ferry Road, and then the other side of Boone's Ferry Road is there. And what is the Boone's Ferry cross? Does anybody know? Is it the Tualatin River? I really don't know. Is it the Willamette?
Yeah.
It crosses the Willamette? I don't know. This is funny. We don't know. But back in the day, everybody knew. I know the Canby Ferry crosses the Willamette, yes? Has anybody been on the Canby Ferry? Yeah. Canby is like south and a little bit east. Yeah? You know? But anyway, the Canby Ferry, we used to go to the pumpkin patch, and then we'd ride the Canby Ferry, right? The Canby Ferry runs on cables and therefore is not pulled downstream. But back in the day, a ferry was a real boat. The real boat loaded you on board, and then the boat operator pointed upstream so that they didn't go downstream. And when they reached the dock on this side, they were actually at the dock. Yeah? That's kind of cool, isn't it? I know. There you go.